sine, cosine, tangent. If you keep your formulas in your mind in this order, like x, y, z, a, b, c, 1, 2, 3, sine, cosine, tangent. If you keep them in that order in your mind, you're going to be able to remember the formulas better. Sine, cosine, tangent is set up with opposite over hypotenuse. That's the sine. That's the formula for figuring out the sine. The cosine is adjacent over the hypotenuse, and tangent is opposite over adjacent. Now that's kind of hard to remember, but if you realize that this spells O, and this is ah, and then we are taking the top number, the numerator of the first one, and the O comes down, and the numerator of the second one comes down for tangent. So what we really have here are the words like, oh, like you understand. Ah, now I get it. And then one of each, the O over the A. So we have O, ah, oh, one of each, in that same order. Sine, cosine, tangent tells you where you are positioned within the triangle. So if you are here at 37, let's say, you have a 5 as the adjacent angle. That one touches the 37. The opposite side from this angle is 6, and the hypotenuse is always across from the right angle. So from the vantage point of 37, this particular point on the triangle, we have adjacent, opposite, and hypotenuse. This switches when we go to this corner. Now 6 is adjacent. 6 is touching this corner. The opposite now becomes 5. And the hypotenuse, of course, always stays 8 because it's across from that right angle. So you must keep your focus on the angle of the vantage point. If you're starting here, then sine, cosine, tangent works off of this point of view. If you switch and go here, then your vantage point also changes. You're still going to get the same answer whether you are here or here, but you're going to be using a different formula to get there. All right, in this particular triangle, I've marked every part of it except this angle right here. This one we can easily figure out because we know that there are 180 degrees in the entire triangle. This one, the right angle, already eats up 90 of it. So the other two angles are the other part of the 90s, right? 90 plus 90 is equal to 180. So if we took these two angles, those also would be equal to 90. It's because this 90 is the right angle, and the other 90 is the addition of the other two angles. So we would have 37 plus something else is equal to that 90. So let's find out what this angle measures. I'm going to subtract 37 from 90. And I find that this angle right here is 53 degrees. Okay, now all of our parts of this right triangle are marked. We can now work with our trigonomic functions depending on where we are within the triangle. So let's look here at 37. We could do a sine. The sine of 37 degrees is equal to opposite over hypotenuse. That's what we're looking for. So we have sine 37 equals opposite, I'm coming over to the 6, over hypotenuse, 8. If I do the cosine of 37, that would be adjacent over hypotenuse. Now I'm going to go cosine of 37 is equal to adjacent, that would be the 5, over the hypotenuse of 8. And if I figure this from the vantage point of the tangent, of 37, the tangent is opposite over adjacent. So the tangent of 37 is equal to opposite 6 over adjacent 5. In each of these cases, this one, and this one should always give me the same answer. It's just that you're going to be doing the calculation with slightly different pieces of information. But ultimately, it works out the same, because when we actually do the calculation on the trigonometry, something that I'm not going to get into right now, that translates to an actual decimal, which translates to a figure that is either a length of the side or a degree of the angle.